Alright, so for example 6, we write the following functions in a piecewise function. So question A, we write the fx equals to negative modulus x minus 3 minus 5 in a piecewise function. Hence, determines its domain and range, and then sketch the graph. So how we write the piecewise function? You must focus on our absolute part. So for absolute x minus 3, it will be separated up by piecewise function. For x minus 3 greater equals to 0, it will be a positive sign. So for x minus 3 less than 0, it will be a negative function. So when I simplify it, so this is still x minus 3. This is for x greater equals to 3. So this one will be negative x plus 3 for x less than 3. That is only for modulus. So how about the whole function? So the whole function, it will be using positive x minus 3 for the domain x greater equals to 3 inside our function. So it will become negative x minus 3 minus 5. And then for x less than 3, it will be using negative x plus 3 for the function. It will become negative x plus 3 minus 5. So finally, simplify our function, negative x plus 3 minus 5. So for this part, positive x minus 3, then minus 5. Simplify until the simplest form. It will become negative x minus 2 and x minus 8. So this is our final answer. So this is how we write our absolute function into a piecewise function. So this is our piecewise function. What's meant by piecewise means in a one graph, it contains different functions here. So the first part is negative x minus 2, and then the second part will be x minus 8. So for example B, where our function is equal to modulus 2x plus 1. Firstly, write our modulus in piecewise. Okay, so 2x plus 1 will be positive greater than 0, so it will become positive sign. So 2x plus 1 will be negative, so the whole function will be times with negative. So when we simplify this modulus part, it will be 2x plus 1, and its domain will be x greater equals to negative 1 over 2. For this part, it will be negative x minus 1. For this domain, it will be x less than negative 1 over 2. Now you have to combine to complete the function. So for 2x plus 1, we will plus 3 for x greater equals to negative 1 over 2. Then we will use negative 2x minus 1 to plus 3 for the domain that less than negative 1 over 2. So finally, we simplify it. So our function in piecewise form, in the simplest function will be, simplest answer will be 2x plus 4, where x greater equals to negative half. And then for another part will be negative 2x plus 2 for x less than 1 over 2, negative. Okay, so that will be our first part of the question, where the question asks us to rewrite the function in piecewise function. Then second part, state the domain and range for this function. So domain and range, we can use back our concept of absolute. So for domain, second part, what's the domain for this function? This is not a special case, so it will be negative infinity to infinity. So what's the range for this function? You must special case close your modulus here. You will see negative 5 and negative infinity. Therefore, it will become negative infinity to negative 5 include. For the question B, the domain of the function is negative infinity to infinity. And then the range. So I need to close my absolute. Then I see positive 3. So it will become included 3 to infinity. Then for the third part of the question, sketch the graph. So now I'm going to sketch this modulus graph. So for this modulus graph, this is downwards, and then where's the point where the x, I can see x is equals to 3. Inside the modulus there, x is equals to 3, and then coordinate y here is negative 5. So therefore my graph will be x equals to 3, y equals to negative 5, and this is my point, and then this is going down, V-shape going down. Lastly, label x, y, 0, fx, and what is the intercept here? Intercept y-intercept, we will let x equals to 0. So when we let x equals to 0, it will be modulus negative 3 minus 5. So simplify, it will be 3 minus 5. So it will be negative 8. Then we will go for question B. Question B, draw this graph. Draw this absolute graph. So absolute graph is a V shape. So this V shape, you can see it is going up because to infinity. And then where's the point? The y is equal to 3 here, and then the x, I need to refer back to the modulus part, which is negative 1 over 2. So therefore, here we label our point negative 1 over 2, and then y is 3 here. So I will going to draw my modulus going up, V shape going up. So I have an intercept here, and then I label y, origin, and fx. So what's my y-intercept? We will let x equals to 0. So it will become modulus 1 plus 3, which is 4. Okay, so done.